we're looking at sizes and units. Sizing and measurement are important parts of everything we do. We need the right size for the clothes we wear, and to get the right size we need to measure it, and to measure it we need units to label or quantify our measurements. In CSS, we measure everything, e.g. the size of the image, position of items to each other, the size of text, etc. So in CSS we have two types of units. We have the absolute units and the relative units. So absolute units are units that are constant, they don't change, and the most common absolute unit is the pixel, which we've been using all along. So the pixel is 1/96th of an inch. So for example, if we should declare a pixel of let's say 10 pixel, okay, we have this text on the screen, welcome to Instinct Up, and we decide to say, okay, we want the font size of this text to be 10 pixel. So let's declare that and let's see how it looks like. So we have p tag, welcome to Instinct Up. We'll come here, we'll say, okay, our p, I want to give it a rule of font size 10 pixel. So this increases the size or reduces the size, so it reduces it from the default font size of the browser. So but we can also decide to increase it 20 pixel, so it increases it. So the pixel is constant, so when we declare 20 pixel, it's going to be 20 pixel throughout any screen size. When we change it in any dimension, it's still going to be 20 pixel. Why? Because it's an absolute unit. But what are relative? We have relative units. What are relative units? These units are measured in respect to something. What are the something? Either the appearance, the viewports of the screen, etc. So for example, now let's look at an example of relative unit. So one example of relative unit is a rem. So a rem is spelled as R. Okay, let me write it in quotes. Rem. So this unit scales against the size of the root element, which is the HTML element. So that's what the rem scales against. So, and we know that for every browser, the default font size for the browser is 16 pixel. So the HTML tag, for example, here, let's check. Let's remove the font size for this P paragraph. You understand? So let's inspect, let's save and inspect, and let's see the default font size. Let's see the computed font size for the P. Let's come to computed. So let's check, let's filter, let's check font size. Can you see? So the font size is what, 15 pixel. I've removed the declaration of 20 pixel from it. So the default font size is what, is 20 pixel. So if you are going to use the rem unit will always scale against this 16. The scale against this font size of 16 pixels. That means it will be relative to 16 pixel. So for example, let's let me close this tab. Okay, no, let me close this. So let me uncomment this. So I think I need to close this. So let me uncomment. So let me give this. Oh, sorry. Let me give a p. Let me give it size of 2 rem. So this 2 rem, what will be the expected size? You can see the size increased. So if you are to inspect now, since we said that rem will scale against the default, the default size of the root element, which is and our root element here is the HTML. And we've inspected our browser previously, we saw that the default font size of the HTML element is 16 pixel. So now that we added 2 rem to our to the paragraph text, what do you think the computed size would be? So the computed size would be 32. Why? Because 16 times 2 will give you 32. So let's inspect and let's check if we are right. So let's check for the font size of the P. Can you see 32 pixel? So the rem will always scale against the default HTML. So another rule of thumb is for you to be able to use the rem, sometimes it's always the default size on the HTML, that's the root element, which is the HTML tag, is always set to like 10 pixel. So you can always declare, like say font size here to be what, 10 pixel. So whenever you're, let's save this. So whenever you write, use a tool, whenever you're using rem throughout your CSS file, it will always scale to like multiple of 10. So when we add the font size of 2 rem to our P tag, now our P element becomes the completed font size of our P element becomes 20 pixel. So let's check. That's 20 pixel. And when you are reading some CSS file, you might not see it as 10 pixel. Most people will write it as 62.5%. So how do they arrive at 62.5%? So that was like, let's see. So we'll come to how they arrive at 62.5%. So let's look at the next. Let's look at the next unit. The next relative unit. So the next relative unit we have is hem. So it's also written as like hem. So the M is different from the rem in the sense that the M scales against the font size of the parent element, especially for properties like font size. So for font size, it scales against the font size of the parent element. So the width also. So the width also of the element, when you use M for width, it scales against the font size of the parent element. So both the font size of an element and the width of an element will always scale against the font size of the parent element whenever you are using M. So let's look at an example. So just before we continue with M, so the way the 62.5% for the M is calculated is the 10%, the 10 pixel that you are trying to convert to. Let me 10 pixel you are trying to convert to divided by the 16 pixel of the browser times 100%. So let me write it in a quote. So this will give you 62.5%. So give you 62.5. So let's take our calculator to calculate it. So we have 10 divided by 16. That's 0.625 times 100. That's 62.5. So that's where we arrive at 62.5%. So this is a conversion from we are trying to convert from 16 pixel to 10 pixel to percentage. So now let's continue with M. So now we have several divs. We have the parent div, which has a child div. The child div has a grandchild div. So now let's set a font of let's save this. So we don't have a P tag anymore. So we just rename this to parent. So we want the size to be 2M. You can see. So you can see the size increased. So since the first parent has a body, the parent of the first parent, the parent itself is body. So but it will inherit the parent of the base element, which is the HTML. And since that's 62.5%, we expect the parent font size to be, let's look at the computed, that's 20 times 2. So for the child, you can see the child, because the child, we've not set any default font size for the child and for the grandchild, but you can see automatically they inherited the child of the font size of their parents. So let's also inspect the font size for the child. Font size for the child is also 20. So let's check for the grandchild also. You can see it's also 20. So let's now declare font size for the child too. So for the child, we have child. Let's give the child also font size of 2M. So what do you think? Let's see. You can see. So the child becomes bigger. Let's say 2 times bigger. So what do you think the computed font size of the child would be now? The computed font size of the child will not be. It can't be. We can't expect it to be 2 times 10 of the of the root element. No, it will be 2 times the size of its parents, and the computed size of the parent is what, 20. So we expect the child to have a font size of what, 20 pixel times 2, which is 40 pixel. So let's inspect. So you can see 40 pixel. So now let's try for the grandchild. So for the grandchild, because currently we can see that the grandchild is using the parent size of it's using the font size of its parent, which is the child, even though we didn't declare anything on the grandchild. So let's now declare something on the grandchild. Let me check how to do the grandchild. Okay, grandchild. So let's declare something like font size to be 3M. Sorry, not M. M. I'm trying to use M. Wow, it's quite big. So what will be the font size of the grandchild now? So the last time we checked, we saw that the computed font size of the child is what, 40. So the computed font size of the grandchild will be what, 40 times 3. That will be 120 pixel. So let's check. Let's check the computed font size. 120 pixel. So that's the way the M works. So whenever you are using M, know that the actual font size you declared. For instance, if you say 2M on a particular element, know that it's the actual computed size that will be used on that element will be relative to the font size of its parent. So let's look at some other relative units. So the other relative units we have VH and V. So please let me remove this grandchild font size because it's too big. So let's see. So we have VH. VH meaning view port height. We have VW. We have view port width. So what's viewport? So this unit stands for viewport width and viewport height. So the viewport width is the total area, screen area that your browser occupies. So that's the viewport. So 1% of that is what we mean by viewport width. So for the height also, the total height from the top of your top screen of your browser to the bottom, that's the viewport, the height of your viewport. So this will use the 1% of that. So let's look at let's try and pin that out on our screen so we can have a clear understanding of what we are saying. So for this parent div, permit me to remove this child, since child and grandchild, so we are not using them anymore. Okay, let me just comment them out. So rather remove them. Sorry. So let me declare another style for the div. So for the div, I'm going to give it a width 100 viewport width. So that means I want it to occupy 100% of the width, because just like we said one viewport is like 1% of the viewport width. So when we say 100, we are targeting 100% of the viewport width. So when we say height also 100, so we are targeting 100% of the viewport height, which is VH. So let's now give it a background color so we can see the total area that is occupied. That will be occupied. Background color will be, let's give it blue. So let's save this. Can you see? So can you see this is the browser within view code sandbox. Can you see the total area occupied? So that's the view. This is the viewport area. So from this point, from this edge of the box here on the right and left hand side to the edge of the box on the left hand side here, that's the viewport width. From the edge of the box here, from the top here to the bottom here, that's the viewport height. So this total area covered by this blue background is the viewport for this background. So imagine we're using an actual browser. If we're using an actual browser, then it would occupy the total area within our browser, the total screen within the browser. That means below from the address bar beneath. So that's the total area. That's the viewport height we are width and height that we are referring to. So let's look at another measurement, another relative unit. So another relative unit that we have is vmin. So let me write this in quotes. We have vmin and vmax. Vmin and vmax. So these are related to the minimum and maximum value of the viewport respectively. So the vmin means that what is the minimum side, the minimum viewport area. It might either be the viewport height, it might either be the viewport width. So what's the vmax? So I'm going to use the viewport with the highest value. So for example now, if we have an iPhone, of let's say of viewport 375 by 812. So when we say 375 by 842, that means we are saying that the width is 375, the height is what, 812. So out of these two values now, the vmin will be the lower value, which is 375, and the vmax will be the higher value, which is 812. So let's try and let's see if we can demonstrate, if we can get the viewport vmin and vmax here. So definitely we know that the vmin here will be the width, and the vmax here will be what, the height. So let's try that. Let me see. So for the height now, I want to give it a value of v. Let me use vmin. Let's see. Can you see that the height reduced? The height of the box reduced. So if you measure from here, the left hand side to the right hand side here, the size will be equivalent to the side here, from the top here to the bottom. Why? Because we've actually given the height the size of the width. Why? Because the viewport width has a lower value on this screen. So if we want to test it out now, let me return this back to the normal viewport height. So let's now give the width the Vmax and let's see what will happen. Can you see? You can see that the size, the width increased. You can see we can see that we are scrolling more. So now the Vmax, the width now has the size of what? Of the height, which is what? 100% VH. So that means we are automatically giving it the dimension for the height. Why? Because our viewport height has the highest value and our viewport width has the lowest value. So by using Vmax now, we are automatically giving it the size for the height, because the height has the viewport height has the higher value. So let me give the height viewport Vmin. Can you see it becomes smaller? And yet you can see that there's still space here. So this guy is not totally occupying the whole viewport for the height. But if I should change the height now to Vmax, it will occupy the total area for the height, the total viewport for the height. Can you see? Now let me now return the width to the Vmin. Can you see? It's occupying the total viewport width now. So this is equivalent to the 100% VW, and this is equivalent to the 100% VH. Why? Because the viewport height has the higher value, while the viewport width has a lower value. So it is equal to the Vmin. So, but for a different screen, it can go either way. Why? Because the width of the screen can sometimes be larger than the height of the screen. So it depends on the screen size. Yeah. So another relative unit that will also come across is the percentage. So whenever you set percentage on a property, such as width, height, or font, it is measured with respect to the parent's property. So what do we mean by that? So for example, if I say let's uncomment this child. Let's comment this guy out. Okay, so let me comment out. Yeah. So let's see. So currently there is no font size on the parents. So let me give it so let me uncomment it. So for the font parents, I'm using, let's see, this is M. So for the parent, I'm using 2M, and based on the root font size on the root, this equivalent to 10 pixel. So we expect the parent to be 2 times 10, that will be 20 pixel. So the child here is 2M. So based on M, the way M works, that will be 20 pixel of the parent font size times 2M, that will be 40. But now we are trying to look at percentage. So we say percentage, any property that uses percentage, the calculation is always based on the parent's property. So now let's say we want the font size of the child to be 20%. So 20% will be based off of the parents. You can see how small it is. So this will be like 20% of 20. Yeah, 20% of 20. So let's calculate 20% of 20. because we know that the font size of the parent is 2 times 10 pixels, that's 20, and we said we want the font size of the child to be 20%. So the 20% will be calculated relative to the parent's font size. So let's look at 20% of 20. Let's look at 20. So let's just inspect and see. I'm suspecting that should be like 10. That's 6 pixels. Wow, that's quite small. That's 6 pixels. So that'll be 20 over 100 times 20. So let's calculate that. Let's see. 20 divided by 100. Yeah, that's right. So that's 20. That's 4 pixels. So 10 pixels minus 4 pixels, that will give us 6 pixels. That will give us 6 pixels. So we can just do the same thing as saying 80 divided by 100 times 20. Font size is, of the child is 6 pixels. That's 20% of the parent's font size. So rather than using font size, we can also decide to use width. So let's try something. Let's do this. Let's say the width of the parent is 90 pixels. I'll give it a background color. I'll say let's say orange. I'll give it a width of 50 pixels. Background color. Red. Can you see? So we can see the parent is occupying like 90%. So but the child is occupying 50% of the 90%. So you can see the portion the child is occupying within the parent. So the child's width is relative to the parent's width. Whenever you are using percentage, know that it's a relative unit, and whatever property you are setting a percentage on will be calculated based on the parent's property.